Hey, what's up, guys? So today is going to be a bit of a different setup. Today I'm going to be doing the 2018 paper, and I'll be going through all the mistakes I have done. Things like question 2, question 5 so far, and kind of just going through that. Okay, so we start off question 1. Question 1 was a simple integration stuff. Then we go question 2. Now question 2, show that x squared minus 8x plus 17, where you would do the discriminant to find out the number of values, and if it's, well, for all real values of x. So we're given this equation, and it's telling us to find x when it's greater than 0. If we use a discriminant, we can prove that all x values are greater than 0. So there we go. So minus 4 is less than 0, which means there are no two roots, which means it's greater than 0. You know how it's like upwards, like this, right? So that could be one solution. But one problem I did do in II is I thought, well, with this proof question, I thought you just had to, I don't know, go with the statement, I guess. I didn't clock that it was one of them. Oh, I forgot what its name is, but I'll show you. So if I add 3 to a number and square it, the result is greater than the square of the original number. State given a reason. If the above statement is always true, sometimes true, or never true. So when we're told if the statement above is always true, sometimes true, or never true, you have to try it out and see if it works. So I didn't do that. I thought, because if you square a number, whether it's negative or positive, it's always going to be positive. And if we add a positive with 3, it's going to always be true. But in theory, that isn't actually possible. So if we try it out, so it's telling us if I add 3 to a number and square the sum, okay? So if I add 3 to a number, so if I add 4 plus 3 and I square it, we would get 7 squared, which gives us 49, rather than the number squared by itself, which is 4 squared, which would be 16. Well, obviously that is greater than that. But then you get into things like negative numbers, not negative numbers, but like ones, for example. So what if actually negative numbers. So if I do minus 2 plus 3, then I would get minus 2 plus 3 squared. That would equal to minus 1 squared. No, plus 1 squared, which would give us just 1. But if we actually do minus 2 squared, we would get 4. But so this is less than this. So with this statement, it is sometimes true. And then we would say why it would be sometimes true. So sometimes true, if I add, so you just copy the statement. Sometimes true because if I add 3 to a number and square the sum, the result will be sometimes greater than the square and sometimes less. So you just have to kind of reword the statement, but we still use the statement as is. Okay, question 3 is fine. Question 4 is fine. Question 5. So the mistake I did is I didn't apply the rules of logs properly. And when you're given a question like this, where you're given a student's attempt, the first thing you would do, well, you should do, is actually attempt it for yourself first and then compare it to what the student got. It would be much easier that way, because if you actually did it yourself and you did it correctly, then it would be much easier to compare. So for this, without even looking at what the student did, I would do this question myself. So I did this myself, but I did it wrong because I didn't apply the right rules of logs. So when we're given things like 2 log 2x minus log 2 root x equals 3, the first thing we would have to do is make sure that both logs are the same. And by that I mean there shouldn't be like any number beside it. So look, if I make log 2 x squared, which is the same as this one, it's the same as this one, I just made sure that it's the same as this one. So it's like it's empty on the left. The coefficient doesn't really have a coefficient now. It's all like squared or turned into a power. That's the first thing we do, okay? And then the next thing we would do is we would begin to divide it, because as the rules of log states that if it's a minus we have to divide, if it's a plus we have to times. In this case it's a minus, so we would have to divide. So log 2 would have to be x squared divided by root x equals 3. We can also change root x to be a half, because that's also the same. And what you would do, that is the same as x 3 over 2 equals 3. And then you apply the rules of logs as well to remove the log on that side and move it to that side. So this would be x 3 over 2 equals 2 to the power of 3. And what I would do personally is I would try to get it, remove the 3 in this kind of way. This is my kind of method. When it's 3 over 2 and equals 2 over 3, 2 to the power of 3, I would begin to cube root every side. Okay, and then with that, I would get equal to 2. Now we're still not finished. We want to find out x only. So we have to square each side, giving us 4. And that would be our answer. And now we look at our method and compare it to the students. Now what the student did was he did it wrong. He didn't apply the right rules of log. So you can see over here, right, he should have made this 2 and placed it there. So this should have been a 2. So that's the first mistake he did. Okay, and the second mistake, I think it just carries on with this. So right, so you see how it's like log 2x equals 3? It shouldn't be 3 2, it should be 2 3. So that's another mistake he has done, or she has done. So it would have to be x equals 2 to the power of 3 instead of 3 to the power of 2. So that's the 2 mistakes the student has done. And you just write down what the student has done wrong. So if I write it down, I would get didn't make logs the same, maybe, or slash didn't square the x. For this one, that's the first mistake. Second mistake would have to be it should have been log 2x equals 3 should have been 2 to the power of 3, not 3 to the power of 2. So we're doing question 7 now. This question kind of really boggled with my mind, I won't lie to you. I even started doing the wrong formula for it. So it should have been half AB sine theta. So I'm going to remove all of this bad working out, and I'm going to... Please rub out. Okay. So it's asking us, in a triangle ABC, side AB has length 10 centimeters. So we do AB, okay, and then we do C as well, right? It doesn't really matter about the length so far. I don't really care. So this is 5, and BAC is theta BAC. This is theta, okay, and AB is 10. Okay, and now it's asking us to find the 2 possible values of cosine considering the area of the triangle ABC is 15 centimeters cubed. Now, the area of the triangle, there's a formula for it, and it goes like this. Half AB sine C. Sine C isn't really, it doesn't have to be sine C necessarily, so this is kind of like sine A, really. So, and that is equal to 50, okay? And now it's telling us to find the two possible values for cosine. Now this is weird, right? Because we're only given sine. How are we going to find cosine? This is what really muffled my mind, I guess. So let's just carry on working it out. Let's plug in the values for AB. Now, when we're told AB, I don't want you to be confused, right? AB isn't specific. It doesn't have to be exactly AB. It just is two values of unknown. It could be ZY. It could be TV. It doesn't matter. Okay, so half, well, we got this unknown and this unknown, and it doesn't matter which one we put first, okay, as long as we get A is equal to something and B is equal to something and we don't keep flipping it around, it should be fine. Okay, so we'll make A 10. It could be 5. You can make it 5. And we'll make B 5. Okay, and this will be sine theta. Okay, and that is equal to 50. Alright, so if I begin to multiply everything, alright, so this is half 50 equal sine theta equals 15. If I divide by half, we get 50 sine theta, that is equal to 30. Okay, and if I begin to divide by 50, we get sine theta equals 30 over 50, which is the same as 5 over 3. 3 over 5, sorry. Okay? Now, the weird thing about this is the fact that we have to use a rule that is kind of unexpected. So, there's this rule that goes like this, and we usually use it for trig identity, but in this case it's a bit weird, but it still counts. So cosine squared theta equals, well, this is the formula for it, plus sine theta squared theta is equal to 1. Okay? In this case, we're trying to find out what cosine squared, well, we're trying to find out what cosine is. So we'll just find out what cosine squared theta is and just divide that to find cosine by itself. Okay? So we're going to make it cosine by itself. So cosine squared theta is equal to 1 minus sine squared theta. Okay? And now we plug in the values for sine and just square that. Okay, so cosine squared theta equals 1 minus sine, well, we're just gonna plug in 3 over 5 squared. Okay, cosine squared theta equals 1 minus 9 over 25. If I use a calculator, I get 1 minus 9 over 25. We get 16 cosine squared theta is equal to 16 over 25. And if we square root that, so if we square root each side, we would get 4 over 5. But keep in mind, it's asking for two values. Now, if we square something, it could be a positive or a minus, plus or minus, right? So this is plus or minus 4 over 5. So the two values of cosine, if I just put it in the box. So two values of cos theta, okay, because it's asking for the two possible values of cosine theta, is equal to plus, well, we don't have to put the plus, 4 over 5 and minus 4 over 5. So that's the two values for cosine theta. Now we're doing part B. Now we found out the two values of cosine. Now the annoying thing about this question is, if you didn't find out the value of cosine at first, you want to be able to do part B. So we found out the two values of cosine. Two values of cosine, or cos theta. That is equal to minus 4/5 and 4/5. Okay? So now we're asked to, given that BC is the longest side of the triangle, now I didn't draw the triangle, we don't necessarily need it. Actually, you know what? No, I'll draw the triangle. So it's going to be like that. A, B, and C, 5, 10, theta. Okay? Given that BC is the longest side of the triangle, find the exact length of BC. Now, what we would have to do in this scenario, okay, we're given the value of cosine theta, not theta, just cosine theta, okay? So, we're given a value of cosine. We're given two unknowns. What do? Cosine rule, okay? Cosine rule goes like this: a squared equals b squared plus c squared minus 2bc cosine a. Now in this scenario, this would be right. So we're trying to find out what a is. This would be our a over here. And we're trying to find out, so we got the values of cosine a, which is these, okay? Now we just plug in the values. So a squared equals, let's get our b, so this would be our b and this would be our c. And by the way, it doesn't really matter which is which, right? This could be our b, this could be our c. As long as it's the right kind of values and the right kind of side, it doesn't really matter. So this would be 5 squared plus 10 squared minus 2, 5, 10 cosine. So we're given two values and we're trying to find out what the longest side is. So we're going to try out either one. So this could be plus or minus 4/5. Matter of fact, I'm going to copy this. Okay. Hopefully be able to paste it. It's not letting me. Hold on. I'm going to copy that. Copy. There we go, it's copied now. It's not letting me. I'm just going to rewrite it. So a squared equals 5 squared plus 10 squared minus 2. Just make it 50. Let's make this 50 as well. It's the same kind of value. Cosine. Let's make this minus 4/5. And let's make this positive 4/5. And now we just plug it all into the calculator, right? For the first one and the second one, if we plug it into the calculator, we get a squared equaling to 45, okay? But for the second one, we get a squared equaling to 205, right? If we square root each side, we get root 45, so a equals root 45, and a equals root 205. Now we're trying to find out, considering it's the longest side, we're trying to find out what value would be the longest. If we do root 45, it wouldn't be the longest because root 45 is equal to 6.7, right? And considering we're told this is the longest side, if we put 6.7 as this, it wouldn't be the longest because now AB would be the longest. This would be unfair. This is 10 and this is 6.7. Hence, that statement would be wrong. And the statement is never wrong. So this wouldn't be 6.7. But if we do root 205, okay, root 205, we get 14.3, And this would actually be right because it would be longer than this and longer than this. So this would be the greatest. So the exact length, it's asking for the exact length. So we want to leave it in a third. The exact length would be 205. Okay, that's our answer. So now I'm going to do question 14. I'm going to reattempt everything. I know I got the first part right, but I'm going to do the full whole 9 marks, really get into that. And so we start off. Circle C has equation x squared plus y squared minus 6x plus 10y plus 9. Find the coordinates of center C and the radius of C. Okay, so the first thing we do is quite simple. We do x, let's just say I got this, x plus 3. Then we always just flip the sign. That's what I do, it always works out. X plus 3 squared minus 9, okay, plus y minus 5 squared minus 25 is equal to, well, plus 9 is equal to 0. Okay, now we begin to tidy up. Okay, so x plus 3 squared plus y minus 5 squared is equal to 25. Okay, now the center and the radius would be equal to this. So the center would be 3 minus 5. Okay, and the radius would be 5, because the radius is always root this. So root 25 would be 5. Okay, now question B is quite difficult. It took me quite a while to understand it, but it's actually not as difficult as you would think. So the line with equation y equals kx, where k is a constant, cuts C at 2 distinct points. If it cuts C at 2 distinct points, that means that, let's just say, this is our circle, this is 3 and minus 5. It would cut at 2 distinct points, so it could cut here and here because it's a line. Okay, it could cut here and here. Okay, but the time it wouldn't cut, it would be here, so it wouldn't cut over here. No, that's not the best line. It wouldn't cut over here because that's only 1 point, or here. Matter of fact, even here or here. But you get my point. It would cut from here and here, or here and here, or it could even go down here. We don't exactly know what values k is, but we can find the range of values, and the way we do that is quite interesting. Okay, so the first thing we would do is, because we're told that y equals kx, with this equation, x squared plus y squared minus 6x plus 10y plus 9, we can plug in the value kx, right? We wouldn't be wrong, I mean, it's the same value, right? So x squared plus kx squared minus 6x plus 10kx plus 9, okay, equals 0. We would try to solve it a little, okay, and we would be left with, actually, I think that's alright, to be honest. In looking at it, we can solve it. So if we try to solve it, we would be 1 plus k squared x squared plus 10k minus 6 x plus 9. Okay, because this would be correct only because, let's say that and that, right? We just take out the x squared, we'll be left with 1 plus k squared. okay? Because the k in this scenario, you know how we squared it? This would be also k squared. Hopefully that makes sense. Okay, I'm going a bit off track here. So this is our solution when we put the value y equals kx instead of the value y, okay? And now what we would do is we would find the discriminant. One good thing about the discriminant is b squared minus 4ac. One good thing about the discriminant is when we use the discriminant, we can kind of, so you know how there's like the coefficient, we can use the coefficient to find out the kind of solutions, if that makes sense. So like, if I show you, I think it would make even more sense rather than me saying it. So this would be our A. So if I just plug in the value A, B, and C, A would be 1 plus k squared. Okay, B would be 10k minus 6, and C would be 9. Okay? And if we plug in them values, right? And by the way, we would know it's greater than 0 because there's two solutions because it hits two distinct points. Okay? We would get 10k minus 6 squared minus 4, 1 plus k squared, that is 9. Okay? That would leave us with, if we solve it all, we'd get 100k squared minus 120k plus 36 minus 36 minus 36k squared. Tidying that up, we would be left with 64k squared minus 120k. Okay? Now, in the mark scheme, well, not the mark scheme, I'm following the model answers here. It begins to break it down even further. Now, I don't think you would have to do that. You can go on your calculator and you select polynomials and treat it like k is in x. Okay? And you would be given the values instantly. So if we put this in calculator, put in calc, we would be given the values k, because instead of putting k, we can put x in the calculator. It's still the same, it's still an unknown. Okay, we would get k equals 15 over 8 and k equals 0. Okay, so these are our values for k, and now we have to find out the values. You know how we were talking about the circle and it has to hit distinct points? It can't be higher, can't be lower than certain points, right? Just like, you know, if I draw it out here, it can, like, there's a kind of ending to it, so it could either be here or something like that. Now we found out what k is, we can say what these points are. So k has to be less than 0, but k has to be greater than 15 over 8. And these would be our values for k. That would be 6 marks. Yeah.